So this is a quick little video guide going over most of the code articles we have talked about in our code class, starting from chapter 1, which is, definitions and just, general stuff, going down to, I believe we ended so far at about 235, which I believe that's where we ended off. We will probably wind up going further in class, but that is to be determined. Let me just get my own code book out so that I know what to point out. All right. So I am currently using the NFPA's free access to the NEC online. You can see up here, that's what the link looks like. You have to make an account, but this allows you to digitally access a PDF copy of the actual NEC's pages. It's not as nice as the one that Troy uses, but it gets the job done in a pinch. So I'm using that because I don't have a good way to like take a video of my book itself. So yeah, that's what we're rocking with for today. So starting out at section 90, we start out obviously with scope. This article covers use and application, arrangement, and enforcements of the code. This kind of stuff, it's the rules on what the code does and does not cover, and how things should be done. Yeah, this first page is pretty self-explanatory. Second page, um, yeah, again, nothing too crazy. The most important thing for us to remember is the arrangement, but we can probably assume our arrangement is going to be the same. I mean, we've talked about it before. Chapters 1 through 4 are our main articles we're ever going to be going over. Chapter 1 is general. It's talking about like definitions, guides, whatever. Chapter 2 is wiring for, just wiring and making sure you're doing your wiring right. Chapter 3 is talking about, how you should wire. Like, chapter 2 is the rules, chapter 3 is the how to. With chapter 3 going over like box fill, box mount, all that stuff as we've gone over in our lab class. And chapter 4 going over um, general equipment use, which is, motors, switches, receptacles, luminaires, appliances, you know, this devices is kind of the catch-all. So, um, we have only ever gone over chapter 1 and 2 in class and chapter 3 in code, or not in code, in lab. So I'll mostly go over chapter 1 and 2. The only thing you're really going to need from chapter 3 is, let me see if I can pull this up here in my book. Right. 185. Let's see if I can do this. There. Okay. This is the only thing that we really need out of chapter 300 specifically for code is the conductor sizing for services, I believe. Yeah, single phase dwelling services and feeders, table 310 dot. Oh, that's the wrong page. No. That's 310.15. I need 310.12. Okay, that's 310.4.4. There we go. Okay, at the bottom here. Service and feeder rating determined by amps. So, determining what size feeder you need for what size service, or what size conductor you need for what size service. So, if you have a 200 amp feeder, you need a 2-aught copper or 4-aught aluminum. Stuff that we've been going over in section 200 recently. And then aside from that, the only other thing out of the way that you might need to know is in 250. Let's see if I can find it here. There is one table that we use about sizing. Yeah, okay, I found it. 159. It's probably going to be off. Move one over, maybe two over. Yeah. So minimum size equipment grounding conductor. This is one other thing we have talked about in class. That's not in a section that we've gone over thoroughly. Um, but it's pretty simple. It's just, if this is your overcurrent device, your breaker, this is what size your neutral needs to be. So, for example, if we're running a 60 amp cable or 60 amp conductors, we need to bring a 10 amp neutral. Let me see. Yeah, 10 amps for the neutral, because we could size it slightly lower than the actual sizing of the hot conductor and the neutral conductor. So aside from that, everything else is going to be covered in this area. So starting out with Article 100 with definitions. Um, yeah, it's definitions, nothing too crazy. Just going over what all we need. Um, just make sure I didn't skip over anything. Yeah, the only thing I didn't talk about from section 90 was I'm gonna move the mic here for a second. Talking about trade sizes, where the actual measured size of a product is not the same as the nominal size. Trade size designators shall be used rather than dimensions. That's where we get, the quarter inch, half inch, 3/8, whatever, knockouts, stuff like that. It's not the exact size, it's the trade size. So it's what people refer to it as. It's essentially just a system for nicknaming. So, yeah. Definitions. As we go through this section, I'm just going to kind of rattle off the ones that I have highlighted so that you can double check that you have these highlighted. Now, please note, everything that we highlighted not everything we highlighted is going to be on the test, and not everything on the test is going to be highlighted. But I will discuss the stuff that we do need to talk over, or at the very least we talked about in class. So, accessible as applied to equipment. Readily accessible, that's a big one. Ampacity, cross there. Appliance. Sorry, I'm getting I'm getting my pages or my actual browser window mixed up with my recording software because it's just kind of screwed up position. But up at the top here, you have arc fault circuit interrupter. That's a very important one. Down further towards the bottom, if it'll let me. Oh, again, excuse me, I'm new to this. Down at the bottom here, your AHJ, authority having jurisdiction. That is, again, a very important one because your AHJ is essentially the boss above your boss. Like, if they say to do something, it's their purview to make those determinations. Okay. Bathroom. Yeah, I mean, pretty simple. It's a bathroom. The big thing is obviously including a sink and one or more of the others. So a sink and a toilet is a bathroom, but a sink and like a countertop technically isn't a bathroom. I think Troy gave us a story about that in class. And then just across goes over to bonded / bonding, bonding conductor / jumper, equipment bonding jumper, main bonding jumper, supply side bonding jumper, system bonding jumper, and branch circuit. Now, I am not aware if there are more that we highlighted under branch circuit. Like, for example, ones that I would think we might want to know is your appliance branch circuit. You like, for example, in Blueprint we talk about having two 20 amp appliance branch circuits in a kitchen. We never as far as I'm aware, we never highlighted appliance branch circuit. But that's something to keep in mind. Like I said, not everything we highlighted is going to be in the test. Not everything that's in the test can be highlighted. Yeah. General purpose, that's your just like a living room lighting circuit or appliance. Your living room branch circuit. So just a bunch of receptacles, maybe some other shit. I don't know. Individual branch circuit. So for example, a washer cord and plug. A washer receptacle that uses a cord and plug would be counted as an individual branch circuit. flipping the page. Branch circuit multi-wire is one that we did highlight, and that I would also recommend knowing, because multi-wire branch circuit, that's... Oh, let me move this. Yeah, multi-wire branch circuit up here. That's with one or more hot wires. So, for example, a split wire system or a 240-volt system, stuff like that. A little further down, there is building, a structure that stands alone or is separated. You know, like a shack, a shed, anything like that. I don't think we have anything else on this side that we highlighted, but... And I know that there's nothing on this page, but one obviously to keep in mind is your cable non-metallic sheath. I don't know if you would go over this, but, you know, or if this would be on the test, but obviously we all know what NM cable is. Just don't get caught off guard with the wording. So let me flip a couple pages ahead, I think. Oh, no, right here. Okay. Circuit breaker is the next thing that we have highlighted. A device designed to open and close a circuit by non-automatic means. You know, a little further down, we have Class 1, Class 2, and then on the other page, Class 3 and Class 4 circuits. All different types of circuits depending on what their purpose is. You know, for example, a Class 3 circuit is for... Yeah. Class 3, for example, is used for stuff like doorbells or fire alarms. Because it is a lower power source, your 12-volt type doorbell work, like we did in that one job sheet. But then obviously, you know, Class 1, Class 2, Class 3, Class 4, that's all stuff we highlighted. Not sure if we're going to go over it. Clothes closet. Non-habitable room or space intended primarily for storage. So, yeah, like your shit under the stairs, basically. All right. Next one that I have highlighted is conduit body. You know, separate portion of a conduit or tubing system that provides access through a removable cover. You know, like a junction box, I would assume. Yeah, boxes such okay, are not classified. Okay. Yeah, so it uses the interior of a system at a junction or two or more sections of the system at one terminal point of the system. So a junction box. I think you could classify a panel as that, but I'm not sure on that one. Then we have, once more, some pages that don't have very much. The only one on this side is converter DC to DC, which, you know, that's... I think AC to AC is a doorbell transformer, so turning it from 120 to 12. So, again, just doorbell circuit. All right. Flip the page. Countertop is going to be kind of a big one, probably. A fixed or stationary surface typically intended for food preparation and serving, personal elevation, so, you know, cleanliness, like washing your hands, stuff like that, or laundering, or a similar surface that presents a routine risk of spillage or larger quantities of liquids upon outlets mounted directly or on or in the surface. So, yeah, your kitchen countertop, if you have a countertop in your bathroom, in your laundry room, maybe a workbench in your garage could be counted as a countertop, I believe. You know, that type of stuff. Device, unit of an electrical system other than a conductor that carries or controls electric energy. So, for example, a switch is a device. You know, your overcurrent device is quite obviously a device, stuff like that. Pulling up here, disconnecting means a device or group of devices or other means by which the circuits of a conductor of a circuit of which the conductors of a circuit can be disconnected from their source of supply. So, you know, your overcurrent device, your switch, a lever pole arm, stuff like that. Dormitory unit is spaced in a building in which group sleeping accommodations are provided for more than 16 persons. We're not the same member of family. So, for example, you know, obviously a dormitory, or I think technically you could class a hotel as that, but it's yeah, something like that. Further down here, you have dust tight enclosures constructed so that dust will not enter. That is very important. Continuous duty. All these duty ones are a little tricky to remember, especially with like what percentages you would class it at, but that's just kind of something you'll need to look over on your own and make sure you get it down fine enough. So yeah, intermittent, alternate intervals, load and no load, load and rest, or load, no load, and rest. Periodic, intermittent operation in which the load conditions are regular, recurrent. So, something that's going to activate maybe like every 2 hours or something. Short time duty, operation at a substantially constant load for a short, indefinite, specified time. So, probably like a lighting circuit, I might assume, in like a shed or a closet. Duty varying, operation at loads and for intervals of time, both of which may be subject to wide variation. So, like maybe a heater system, maybe a motor system, that type of thing. Dwelling, the different types of dwelling: one family, so a single house; two families, so like a duplex; multifamily, like an apartment building; dwelling unit, so an actual independent living facility for people. So, for example, a studio apartment is a dwelling unit. A one-bedroom apartment is a dwelling unit. Apartments type thing. Uh, Scrolling down, we have electric vehicle. So, a vehicle that runs primarily off of electricity I think it says something about, yeah, primarily powered by an electric motor that draws current from a rechargeable storage battery, fuel cell, PV array, or other source of electric current. And then plug-in hybrid electric vehicles are electric vehicles having a second source of motive power. My apologies there. Skip a page. Then over here, the only one we have is energized, electrically connected to, or is a source of voltage. Pretty simple. Hit the page again. Fault current. Current derived at a point in the system during a short circuit condition. So, essentially, that is your unintended path to ground, or the current on an unintended path to ground, obviously from a short. A little lower than that, you have feeder, all circuit conductors between the service equipment, the source of a separately derived system, or other power supply source. So, example being, your connection from your main to your sub panels. Like, for example, our house, we have a main on the north side. It comes down, feeds a panel in the garage, feeds a panel in our basement. That's a feeder. Pretty simple. Next page. Fitting an accessory such as a lock nut, bushing, or other part of a wiring system that is intended primarily to perform a mechanical rather than electrical function. Yeah, so like it says, lock nut. That's what we use to keep our NM connectors in place, so that we don't have shit flinging around. Yeah, pretty simple. Up here we have garage, a building or portion of a building in which one or more self-propelled vehicles can be kept for use, sale, storage, rental, repair, exhibition, or demonstration purposes. It's pretty simple. It's where you keep your cars, your trucks, your four-wheelers, your tractors, stuff like that. Lot further down, you have ground the earth, so, connecting back to the earth, basically, is grounding. Then, right at the top of the next page, you have ground fault, an unintentional electrically conductive connection between an ungrounded conductor of an electrical circuit and the normally non-current carrying conductors. So, for example, a connection between your hot wire and your grounding conductor, not your grounded conductor. So, your hot wire and your bare wire, or even your white wire and your bare wire. So, that's what that's meaning. Over to the next side, you have grounded, connecting to ground or to a conductive body that extends the ground connection. So, yeah, you can connect a device to wires that connect to a box. So, grounding it with a grounding wire to a ground nut to a ground screw to a box that then is connected to maybe something else. Um, or maybe connecting your hot current to a grounded conduit, I believe, is something that we've been talking about recently. Or grounding piece of conduit, something like that. A little further down, there is grounding conductor equipment. That's your EGC. That's, what we've gone over a lot. That's what you need in most device boxes. That's your bare copper wire. Grounding electrode, a conducting object through which a direct connection to Earth is established, and then electrode conductor. Conductor used to connect the system grounded conductor or the equipment to a grounding electrode. So that's basically your connection between your grounding electrode, which is your main, I'm going to say your main ground in air quotes, um, and the ground that controls the rest of your system. So maybe like your terminal. Or at least that's how I'm going to interpret that. If you guys have a question on any of these, I would definitely recommend getting some answers from Troy rather than myself. I might have an answer, but obviously he's the person who will have all the answers. Anyways, habitable room, a room in a building for living, sleeping, eating, cooking, but excluding bathrooms, toilet rooms, closets, hallways, storage, or utility spaces in similar areas. So, your bedroom, your kitchen, your dining room, your living room, but not your bathroom, not your closet, not your hallway. Into the next page, there is up here. Is it up there? Yeah, it is up there. In sight from / within sight from equipment that is visible and not more than 50 feet distant from other equipment is in sight from that other equipment. So, for example, if you're looking at something and you can see another thing within 50 feet of the first thing that you're looking at, that other piece of equipment is considered within sight from. A little bit further down, you have your interrupting rating, the highest current at rated voltage that a device is identified to interrupt under standard test conditions. So, for example, your interrupting rating on a GFCI is between 4 and 6 milliamps. Intersystem bonding termination, a device that provides a means for connecting intersystem bonding conductors for communication systems to the grounding electrode system. I don't think we've talked about that aside from highlighting. Alright. Inverter, equipment that changes DC to AC. On the other side, you have kitchen, an area with sink and permanent provisions for food preparation and cooking. Labeled and then listed are going to be the big two that are important to remember the difference between them. Now, remember, on your code test, you will have access to your book, but it's important to know these going in so that you don't have questions about them. Labeled is equipment or materials to which has been attached a label, symbol, or other identifying mark of an organization that is acceptable to the AHJ and concerned with product evaluation, that maintains periodic inspection of production of labeled equipment or materials, and by whose labeling the manufacturer indicates compliance with appropriate standards or performance in a specified manner. So, what does that mean? If an object is labeled, that usually means it's going to have a company's logo on it, aside from the ones that made them. For example, Underwriter's Laboratory, that UL, you're going to see that on basically every outlet, or every receptacle outlet, every switch, maybe light bulbs, I'm not sure on that one. But if you don't see it on there, and you don't see a label from another company that is considered within parity of UL, do not use that product, as it's either a knockoff or it's made illegally, which, I mean, at that point it's splitting hairs, but, point still stands. You need to have your UL label. Underneath that is laundry area, an area containing or designed to contain a laundry tray, clothes washer, or clothes dryer. So, pretty simple. Next page. Lighting outlets. An outlet intended for the direct connection of a lamp holder or luminaire. Pretty simple. And then we get to listed equipment, materials, or services included in a list published by an organization that is acceptable to the authority having jurisdiction and concerned with evaluation of products or services, that maintains periodic inspection. and meets appropriate design standards or has been tested and found suitable for a purpose. So the difference between listed and labeled is that listed means it is within, for example, let's say a book of okay products to use. An item has to be labeled before it can be listed, because labeled means it's been inspected by a company. Listed means it is within proper usage according to your AHJ or your contractor. Roughly. Again, if you're not sure on that, feel free to ask Troy. I assume that he would be more than willing to help clear up that if you're unsure on that. Anyways, damp, dry, and wet locations. So, damp location. Locations protected from weather and not subject to saturation with water or other liquids, but subject to moderate degrees of moisture. For example, your bathroom, your kitchen, your laundry room, areas that, generally there might be some humidity or condensation. Location dry. A location not normally subject to dampness or wetness. A location classified as dry may be temporarily subject to dampness or wetness, as in the case of a building under construction. So, for example, this would be maybe a factory where you are manufacturing. I, I really don't know what to say on that one. Yeah, not certain. Location wet, a location that is one or more of the following: unprotected and exposed to weather, so like an outdoor location and location without any walls. Subject to saturation with water and other liquids, so an area that maybe has open sprinklers, so like a greenhouse. Underground, pretty self-explanatory. In concrete slabs or masonry in direct contact with the earth, so like a storm cellar. Okay. Next page is luminaire, a complete lighting unit consisting of a light source such as a lamp or lamps together with the parts designed to position the light source connected to the power supply. So, for example, like a fan can count as a luminaire. A sconce can count as a luminaire. A recessed, like a wafer, is a luminaire technically, because it is a complete lighting unit consisting of the light source itself, as well as parts designed to position the light source and connect it to the power supply. Next, messenger wire, a wire that is run along with or integral with a cable or conductor to provide mechanical support for the cable or conductor. So, for example, a support wire is a messenger wire in this scenario, I would assume. Next page. Multi-outlet assembly, a surface flush or freestanding assemblage with a raceway and fittings or other enclosure provided with one or more receptacles for the purpose of supplying power to the utilization equipment. So, for example, many of us have probably walked past James's office when his door is open. He has a multi-outlet assembly there, which is that long strip of outlets along the wall by his desk. So, think of it like a power strip built into the room itself. That's kind of the best way I'm going to be able to phrase that, I think. Neutral conductor. The conductor connected to the neutral point of the system that is intended to carry current under normal conditions. So, for example, our white wires are our neutral conductors. That is our grounded wire. But it's better to just use neutral, because you don't get grounded and grounding confused as often. Okay. Outlet. A point on the wiring system at which current is taken to supply utilization equipment. Pretty simple. Basically, anything connected to a circuit that takes power, including lights and maybe switches. I know, for example, our dimmer switches take power, but yeah. Overcurrent protective device, branch circuit. A device capable of providing protection for service feeder and branch circuits and equipment over the full range of overcurrents between its rated current and its interrupting rating. So, for example, a breaker. That is an overcurrent device. A branch circuit overcurrent protective device is, so basically anything that could be counted as a GFCI. So something made to interrupt an overcurrent, which can include a fault current. A little further down here, overload, operation of equipment in excess of normal full load rating or of a conductor in excess of its ampacity that, when it persists for a sufficient length of time, would cause damage or dangerous heating. And then I have this highlighted as well. A fault such as a short circuit or ground fault is not an overload because it's technically a separate thing. Yeah. Panel board, a single panel or group of panels units designed for assembly in the form of a single panel, including buses with automatic overcurrent devices and equipped with or without switches for the control of light, heat, or power circuits. Yeah, I think most of us know what a panel board is. Let me flip my page here. Photovoltaic cell, or PV solar cell, the basic photovoltaic device that generates the electricity when exposed to the light. Or DC electricity, yeah. We know what that is. It's the solar panel, or the thing inside the solar panel. Plenum, a compartment or chamber to which one or more air ducts are connected and that forms part of the air distribution system. So I would assume, like, for example, in my room, I have some air ducts above me right now because I have a drop ceiling and one of the panels is missing. So, for example, there's a big, like, sheet metal box that is part of our air vent system, I'm going to say. There's a reason why I'm not going into HVAC. I'll tell you that much. Because I do not know exactly what the correct term there is. Right. Right over here now. Qualified person, one has the skills or knowledge related to the construction and operation of electrical equipment and installations and has received safety training to recognize and avoid the hazards involved. So, somebody who is past their journeymans or is reasonably expected to know what they're doing. So maybe not somebody who has a journeyman's, but somebody who has a degree or a certification. Raceway, an enclosed channel designed expressly for holding wires, cables, or bus bars with additional functions as permitted in this code. So, a piece of PVC could be counted as a raceway going um, into a panel board. Okay, it's just down here for some reason. Rainproof. Constructed, protected, or treated so as to prevent rain from interfering with the successful operation of the apparatus under specified test conditions. Okay. Rain tight, constructed or protected so that exposure to a beating rain will not result in entrance of water under specified test conditions. So, the difference from these two is that rainproof prevents rain from affecting the device, while rain tight prevents rain from getting into the device altogether. So a box would be rain tight, a device would be rainproof. Receptacle, a contact device installed at the outlet for the connection of an attachment plug or for the direct connection of electrical utilization equipment designed to mate with the corresponding contact device. That's the female end of a plug or, an outlet, as most people would call them. Well, not necessarily, because that's a receptacle outlet, which is down here. But receptacle is, something very similar, just not usually the same. A duplex is a receptacle, but not every receptacle is a duplex, basically. Well, I shouldn't even say that because a duplex is a type of receptacle outlet. Every receptacle outlet is a type of receptacle, but not every type of receptacle is a receptacle outlet. That's what I'm going to say there. Then we skip 2 pages, or at least 1 page. Second page, maybe. No. Oh, that's a lot of stuff. All right. Service. The conductors or equipment connecting and serving utility to the wiring system of the premises served. Service conductors. The conductors from the service point to the service connecting means. Service conductors overhead. The overhead conductors between the service point and the first point of connection to the service entrance. Conductors at the building or other structure. We have been talking about this in code recently. Service conductors underground. The underground conductors between the service point and the first point of connection to the service entrance. Conductors in a terminal box, meter, or other enclosure. Yeah, we get that. Service drop. The overhead conductors between the serving utility and the service point. So, for example, that is your conductor coming from your overhead service to your house. Again, what we have been talking about. Service lateral. I should probably move this. Service lateral. The underground conductors between the utility electric supply system and the service point. Yeah, so that's just, I would assume that's basically our service entrance cable type of thing. All right, a little further down here. Wrong thing. Short circuit current rating. Prospective symmetrical fault current at a nominal voltage to which an apparatus or system is able to be connected without sustaining damage exceeding defined acceptance criteria. So essentially, how much overcurrent a device can take. So if it's too much, then it might break it, but it will still take it out. Show window. Any window, including windows above doors, used or designed to be used for the display of goods or advertising material, whether it's fully or partly enclosed or entirely open. So essentially, a window used to display items, like a display window, basically. Okay, up here. Special permission, the written consent of the authority having jurisdiction. This is their permission to either it's their permission for you to break the rules. So, for example, there are certain parts of code that states will amend. This is essentially the same thing, but for an authority having jurisdiction. So, this might not apply from one town to the other, like how an amendment would apply to generally the whole state. But it serves a similar purpose, is what I would describe it as. All right. Skip page. Where am I at here? Okay. Surge protection device. Protective device for limiting transient voltages by diverting or limiting surge current. It also prevents continued flow of the flow current or a follow current while remaining capable of repeating these functions as is designated as follows. 1. Permanently connected SPD is intended for installation between the secondary of the service transformer. I'm just going to skip reading all this because this is already almost 45 minutes. But you get the point of it's basically there to interrupt overcurrent, kind of. Yeah. Like I said, we'll have our books for the test, so. Switch general use. A switch intended for use in general distribution and branch circuits. It is rated in amps and it is capable of interrupting its rated current at its rated voltage. So, for example, a 125 volt 15 amp switch will work on a 120 volt home circuit. But if you were to put a 120 volt or 125 volt switch into a 240 volt circuit, it probably isn't going to work as well, if at all. You might have a boom boom. I don't know why I just said that. Okay, up here, tap conductor. A conductor other than a service conductor that has overcurrent protection ahead of its point of supply that exceeds the value permitted for similar conductors that are protected as described elsewhere in 240.4. Okay, there we go next. All right. Ungrounded, not connected to ground or to a conductive body that extends the ground connection. So something is hot, then it is ungrounded. Or if it has the potential to become hot, it is ungrounded, I guess is what you could say. Uh, Voltage nominal. So a nominal value assigned to a circuit or system for the purpose of a conveniently designating its voltage class. So 120, 240, 480Y to 277, 600 is the examples that they give. This is what we mean when we talk about 120 volt, 240 volt, stuff like that. Back over here, we have voltage to ground. For grounded circuits, the voltage between the given conductor and that point or conductor of the circuit that is grounded. For ungrounded circuits, the greatest voltage between the given conductor and any other conductor of the circuit. Okay. So what this is talking about is, I'll pull up Microsoft Paint here. That's the wrong tool. I don't know how to draw a delta transformer, but that is okay. So each of these points is 120. That's really bad 120. And this is going to be our ground. So from this point and this point to ground, that's 120 volts to ground. Forgive me, I'm drawing with a mouse. But for this one, because it has to go through another section, it would be, I believe, 240 to ground. I'm pretty certain that's correct. I'm not sure, though. You'll probably want to brush... I'll probably brush that up with Troy at some point and put out a correction. After that, there's watertight, which constructed so that moisture will not enter the enclosure under specified test conditions. So, something that is sealed to prevent condensation or moisture from coming through. Weatherproof. I do not have weatherproof highlighted. Not sure if that's correct or not, but constructed or protected so that exposure to the weather will not interfere with the successful operation. So, for example, an outside outlet needs to be weatherproof. I believe. No, it has to be weather resistant, but it's something like that. Anyways. Work surface. A fixed stationary or portable surface typically intended for dry use and for tasks other than food preparation, personal elevation, or laundering that presents an incidental risk of spill. It's the same thing as a countertop. So, yeah. Anyways, we'll go through the rest of 110, and then I'll cut the video. Let me actually double check that, make sure that I want to go over the rest of 110. Okay, we'll go over the start of 110 because there's not much else afterwards. But 110... Shit. 110 is general requirements for electrical installations. So, we go up here. Examination, identification, installation, use, and listing product certification of equipment. So, examination and judging equipment considerations such as the following shall be evaluated: sustainability, or suitability, mechanical strength, wire bending and connection space, electrical installation, heating effects, arcing effects, classification by type, size, voltage, current capacity, and specified use, cybersecurity for network-connected life-safely equipment to address its ability to withstand unauthorized updates from malicious attacks while continuing to perform its intended safety functionality. So, making sure that what you're using is proper for how you're using it. Installation and use. Equipment that is listed, labeled, or both, or identified for use shall be installed and used in accordance with any instructions included in the listing, labeling, or identification. So, do your job right. If it's telling you install it this way, don't install it a different way unless you have something from your AHJ saying otherwise. Listing. Product testing, evaluation, and listing, product certification, shall be performed by recognized qualified electrical testing laboratories and shall be in accordance with applicable product standards recognized as achieving equivalent and effective safety for equipment installed to comply with this code. So, again, if something is listed, that means it has been tested by a company and is properly certified to be good enough to use. Then skip over voltages. Conductors. Conductors used to carry current shall be of copper, aluminum, copper-clad aluminum, or tinned copper. Also counts, unless otherwise provided in this code. So, always use copper, aluminum, or copper-clad aluminum. Yeah. I mean, you're never really going to go on a job site and get anything other than that, I'm assuming. Conductor sizes. Conductor sizes are expressed in American wire gauge or in circular mills. We have that whole chart at the end of the book, I believe. Mechanical execution of work. Electrical equipment shall be installed in a professional and skillful manner. That's 110.12. We should all know that. Unused openings. That is something we have talked about in the lab. That's just stating that unused openings, other than those intended for the operation of the equipment, shall be closed. So close unused openings. That's why we have knockout plugs. Mounting and cooling of equipment. Mounting electrical equipment shall be firmly secured to the surface on which it is mounted. Wooden plugs driven into holes in masonry, concrete, plaster, or similar materials shall not be used. So don't use like a wooden stake or something. Use a proper metal screw. I need to go back. Cooling. Electrical equipment that depends on the natural circulation of air and convection principles for cooling of exposed surfaces shall be installed so that room airflow over such surfaces is not prevented by walls or by adjacent installed equipment. For equipment designated for floor mounting, clearance between top... Yeah. Electrical equipment provided with ventilating openings shall be installed so that walls or other obstructions do not prevent the free circulation of air through the equipment. So don't block ventilation areas on a device. Like, for example, on the back of a computer, you have a exhaust fan that is supposed to blow out hot air. Don't put that against your wall, as just a good example. That's also why you don't put your laptop on your bed or on your lap. Electrical connections. Because of the different characteristics of the similar metals, devices such as pressure terminal or pressure splicing conductors and soldering lugs shall be identified for the material of the conductor and shall be properly installed and used. Essentially, what they're saying is if it's not rated for use with something like aluminum, don't use aluminum. This is the whole CO/AL or the CU/AL and then the COALR that we talked about in Blueprint recently. A little further down, temperature limitations. Don't use wire above its temperature limitation. Obvious. Terminal connection torque. Tightening torque values for terminal connection shall be indicated on equipment or in installation instructions provided by the manufacturer. Yeah, just make sure that you get it torqued enough that it's going to stay seated. High leg marking. On a 4-wire delta-connected system where the midpoint of one phase winding is grounded, only a conductor or bus bar having higher phase voltage to ground shall be durably and permanently marked by an outer finish that is orange in color or by other effective means. Okay. Arc flash hazard warning. Electrical equipment such as switchboards, switch gears, and closed panel boards, industrial yeah. If it has a chance to arc, it needs to be properly marked. We're going to go one more page. Okay. Identification of disconnecting means. General. Each disconnecting means shall be legibly marked to indicate its purpose unless located and arranged so the purpose is evident. So, for example, on a panel board in a house, you're usually going to have, obviously, your switches or your breakers. Then on the right, you're going to have, like, a whole thing listing out each breaker, and you're going to have words that tell you what each breaker does. So, like, for example, in my house, we have a 240-volt breaker. It takes up slots 1 and 3 that is marked on the sheet next to the panel board that says range. Pretty simple. Available fault current. Service equipment other than that dwelling unit shall be legibly marked in the field with available fault current. The field mark. So essentially, generally, you have to state, if a fault were to occur, this is how much voltage would be available, is my understanding. Not certain about that. Okay. Part 2, 1000 volts nominal or less. Spaces about electrical equipment. This is one that I know I had some trouble with, and I think a lot of other people had some trouble with. So, spaces about electrical equipment. Working space and access to and egress from working space shall be provided and maintained about all electrical equipment to permit ready and safe operation and maintenance of such equipment. Open equipment doors shall not impede access to and egress from the working space. It's impeded if one or more simultaneously open equipment doors restrict working space access to be less than 24 inches wide and 6.5 feet high. Okay. Go over here. Depth of working space. talking about how deep it has to be based on these specific code articles. We'll get to that. Or we'll get to them down here, literally. Width of working space. The width of the working space in front of the electrical equipment shall be the width of the equipment or 30 inches, whichever is greater. So if you have a panel board that's like 60 inches wide, then it needs to be 5 feet. Then you need to have 5 feet of space across. But if it's like a foot and a half, it needs to be 30 inches, whichever is greater. Height of the working space, 6.5 foot of the height of the equipment, or whichever is greater. The working spaces. This again, this is one that I think got a lot of people. I'm not sure, but just remember, depending on your nominal voltage to ground, you need to have certain distances. So, for example, yeah, I mean, yeah. Make sure that you know all your conditions. Condition 1, expose live parts on one side of the working space and no live or grounded parts on the other side of the working space. Expose live parts on both sides of the working space that are effectively guarded by insulating means. So, yeah, basically this table applies where these conditions are found, as it says in that note down there. A little bit further up, limited access for equipment operating on 1,000 volts nominal or less to ground and likely to require examination, adjustment services, or maintenance while energized is required by installation instructions or function to be located in a space with limited access. All of the following shall apply. Where equipment is installed above a lay-in ceiling, there shall be an opening not smaller than 22 by 22, or in a crawl space, there should be an accessible opening not smaller than 22 by 30. Okay. The width of the working space shall be the width of the equipment enclosure, or a minimum of 30 inches. Again, going back to that 30 inches over here, it's basically the same thing. All enclosure doors or hinge panels shall be capable of opening a minimum of 90 degrees. 90 degrees is a right angle. Remember that. The space in front of the enclosure shall comply with the depth requirements of Table 110.26a, which is this one down here, and shall be unobstructed to the floor by fixed cabinets, walls, or partitions. So, the space in front of your enclosure needs to be free of everything within a certain distance. Okay. Clear spaces. Working space required by this section shall not be used for storage. So don't put like boxes of parts in front of the device that you're working on. Put them to the side, behind you, or outside of the area if it's that small. Entrance to and egress from working space minimum required. Large equipment. For large equipment that contains overcurrent devices, switching devices, or control devices, so a panel board, there shall be one entrance to and egress from the required working space not less than 24 inches wide and 6.5 feet high at each end of the working space. This requirement shall apply to either of the following conditions. So if your equipment is rated over 1200 amperes or more and over 6 foot wide, so that one I know got me. That's not saying that your area has to be 6 feet wide. It's saying if your devices are if your equipment is over 6 feet wide. And then for service disconnected means installed in accordance with 230.71b, the combined amp rating is 1200 amps or more, where the combined width is over 6 foot. A single entrance to and egress from the working space shall be permitted where either of the conditions in those previous code articles are met. Unobstructed egress for the location permits a continuous and unobstructed way of egress travel. A single entrance to the working space shall be permitted. Extra working space where the depth of the single device or the single working space is twice than required by 1.10.26a1. So that chart we were just talking about. A single entrance shall be permitted. It shall be located such that the distance from the equipment to the nearest edge of the entrance is not less than the minimum clear distance specified in the previous table for equipment operating at that voltage and in those conditions. Okay. What does that mean? It means if your area is larger than required, you need to still meet those requirements of where you need to have space for your door. Okay. Personnel door. Where equipment rated 800 amps or more that contains overcurrent devices, switching devices, or control devices is installed, and there's a personnel door intended for entrance to and egress from the working space less than 25 feet from the nearest edge of the working space, the door shall open at least 90 degrees in the direction of egress and be equipped with listed panic hardware or listed fire exit hardware. So essentially, you need to have a door that allows you to open it in case of a fire, in case of electricity going out, and that opens pushing out. So when you go into the area, you need to pull the door. When you're leaving, you need to push the door, essentially. You can't have the door come into the space. It needs to exit from. Illumination. Illumination shall be provided for all working spaces about service equipment, switchboards, switchgear, closed panel boards, or motor control centers installed indoors. Control by automatic means shall not be permitted to control all illumination within the working space. What does that mean? You can have like automatic sensor lights in a working area. However, you need to have some sort of means to control those lights. I believe, yeah. You need to have some sort of. Hold on, let me reread that. Controlled by automatic means shall be not be permitted control. Okay. Yeah. So control by automatic means shall not be permitted to control all illumination. So you can have sensor lights, but you need to have some sort of lights that are either controlled by a switch, some other disconnecting means, or like yeah, a switch or some other connecting means. So what does that mean? You can have automatic lights, but you need some other lights. So for example, in a lot of buildings they'll have security lights that are active at all times that you still can turn off, but by default they remain on at all times. So for example, the lab has these lights. Dedicated equipment. All service equipment, switchboards, switchgear, panel boards, and motor control centers shall be located in dedicated spaces and protected from damage. So you can't have like your controls in the middle of a building or in the middle of a room full of other equipment. Indoor installations shall comply with 110.26. Oh, my bad. Shall comply with 110.26 E1A through E1D. Yeah, a bunch of other stuff here. Outdoor spaces have to comply with the stuff below that, and then I believe that is it for 90 through 110 and chapter 1 as a whole. Okay, so this video is about an hour long. I will make another video going over parts in 200, which will probably be split into two. So yeah, uh, hopefully this has been helpful. Yeah, you know where to. I don't know what to say. Like I said, hopefully this will be helpful. If you have any other questions, let me know. But also know that you can always ask Troy or James or Angelia or Phil, anybody.